We're looking at 6.2a, verifying trig identities. So these might be a little bit simpler than simplifying, and the reason is because you kind of know what direction you're going by looking at the other side of the equal sign. So here are the guidelines to follow. So work at one side at a time. So just pick one side, and you want to simplify that one side to match the other side. Look for opportunities to factor, fractions with common denominators, square binomials, using identities. And if any of those don't work, try converting all terms to sines and cosines. And always try something. Don't just leave it blank because you don't know what to do. At least try to find something, and that's better than nothing. So let's look at this first one. Secant y cosine y equals 1. So look at your formula chart. Secant y. It can be simplified as 1 over cosine y. And then we'll keep cosine y. Well, this is over 1. So you're multiplying, so these simplify out, and so we get equals 1, which is what we want. So we were able to get that one. Okay, let's look at the next one. Sine squared t tan squared t equals cosine squared t. Okay, we don't have any plus ones or minus ones, so we're not going to use the Pythagorean one. Instead, let's look at this one. This works the same if you put squares on them. So that means I'm going to replace this with that. So I have the sine squared t over, I'm going to put this in parentheses, sine squared t over cosine squared t. And I know I keep change flip. Okay, and then these cancel each other out. So that leaves me with cosine squared t, which is what I want. Okay, let's go to the next one. Cotan squared beta, cosecant squared beta, 2 cosecant beta. All right, let's see. I'm going to look at this cotan, because that would be like our Pythagorean identity. So I'm going to look back at that. So cotan, it's this one right here. So it'd be, if we minus 1 on both sides, we would get cotan by itself. So I'm going to replace this guy with cosecant squared beta minus 1. And then let's carry everything down. Okay, and I just combine like terms. I really don't need those parentheses there, so I'm going to take them off. And I have 2 of these, so I'm adding, I'm not multiplying. So whenever you do that, you would just change your coefficient. And there we go. That is it. Okay, let's look at our next one. Okay, so we want sine to change into cosine. We have this squared. We have 3 there. So let's look at our Pythagorean identity. In order to get sine, we would subtract cosine on both sides. So we can replace sine squared with 1 minus cosine squared. So I'm going to leave this here. 1 minus cosine squared x. Okay, and then we don't need the parentheses. Combine like terms. Get 4 minus cosine squared x, which is what we get. Okay, so the reason I get rid of the parentheses is because we're adding or subtracting. If we were multiplying, we couldn't just do that. We'd have to distribute, but we are adding and subtracting here. Okay, let's look at the last 2. It says look on page 490. We're not. We're going to look at formula chart. At all of our identities. Okay, so this looks kind of weird, right? We have not seen anything like that with the pi over 2. We've seen pi over 2 with our graphing, but not with identities. So let's see if there's any clues on our formula chart. This is something we have not looked at yet. These are the cofunction identities. Okay, so cosine, which is what's on top, pi over 2 minus u. Well, we can replace u with x because u is interchangeable with whatever variable you want to use. So we can replace the cosine that's on the top of our fraction with this sign. Then we can replace the denominator, which has the sign, for cosine. So let's do that. So I'm going to write myself a note. Cofunction identities. Where did my page go? There we go. All right. So this whole thing is sine of x. And this whole thing is cosine of x. Oh, that's a lot easier than I was thinking, right? Okay, and cosine over, or sine over cosine, we want this to equal tan. So look at your formula chart again. Tan is sine over cosine. So that's a perfect match. So tan, this equals tan of x, which is what we wanted. Woohoo. Okay, this other one's going to take a little bit more work. We got a lot going on here. So let's see what we can do. We have this out front and this out front. We'd really just need to distribute it inside. So this will be secant to the 7th x and then tan x minus secant to the 5th x tan x. Okay. And then they both have secant and tan. So I'm going to factor out secant to the 5th x and tan x. And when you factor out, you have to subtract your exponent. So this would be secant squared minus 1. Okay. So let's see if there's anything I can do. I'm going to look inside here because this kind of reminds me of the Pythagorean identity. So let's look and see. And it is, if I subtract 1 on both sides of the second one right here, then I would get tan equals secant minus 1. So I can replace the secant squared minus 1 with tan. So that's what I'm going to do. Oh, I forgot my x here. Okay, and so this is secant 5th x tan x times tan x. Tan squared x, sorry, forgot that. Okay, so then we can multiply, and that would be tan cubed x, which is what we wanted. Don't forget your x. Okay, okay, but there is more than one way. So this is option 1. Here is option 2. So it just shows you that you can do it in multiple ways. So I'm going to rewrite this. I'm going to do a different color so we can kind of compare them. Okay, so instead of distributing in our secants, couldn't we factor this out of both? That's what I'm going to do. So secant x tan x, secant 6x minus secant 4x. Okay, and then I can factor out a secant squared. So I have secant x tan x times, I'm factoring out secant squared x, and that leaves me, oh no, it wouldn't be squared, it'd be to the 4th because they both have at least a 4th power. So that would leave me with secant squared x minus 1. Okay. So then I'd go ahead and simplify that because I'm multiplying. So whenever you multiply, you can just add your exponents. So secant to the 5th x tan x. Okay, let's look at this. This reminds me of Pythagorean, which we did that a minute ago. Remember? We did it right here. So I'm going to replace that with tan squared x. Okay, then we multiply, and we get secant to the fifth x, tan to the third x. And that's where we want to end. So it also comes back up to that.